Welcome back, Pre-Calculus. We are on number 17 of 9.2. If I can find it again. All right, for this one, we got r is equal to 5 minus cosine theta. So when I see the plus or minus there, I know we're talking about a limison of some sort. For this one, my a is 5, my b is 1. So this is 5 over 1, which is most assuredly bigger than 2. So we know we're talking about our very last example, which is get up here so we can look at it. So we're talking about one of these four, right? And our a over b was bigger than 2, so we're talking about a convex limison. So that's kind of our flat tire looking graph. Here we go. Convex limison. I do want to say, I didn't mention it up here, but this guy, I said it was polar axis, that it was symmetrical. This was back to yesterday, but notice this one is also symmetrical about the pole and about theta over 2. Theta is equal to pi over 2, I'm sorry. So I just realized that as I was moving on. All right, because this one is cosine theta, what is it going to be symmetrical about? Our polar axis. And we will see this one is not symmetrical about anything else. First thing we look at is our maximum R value. Well, cosine theta oscillates between -1 and 1. So if it's -1, then this value becomes 5 minus a minus 1. 5 minus a minus 1 would be 6. And if the cosine theta is 1, we got 5 minus 1, which is 4. So our maximum R value is going to be 6. And that is when what? 5 minus cosine theta is equal to 6. When we subtract the 5 over, I get 1 is equal to minus cosine theta. Dividing by -1, I get -1 is equal to cosine theta. And where is cosine theta equal to -1? That is at pi. So we know at pi, at theta equals pi, we are at 6. So when we're on pi, we're going to be all the way out here at 6. Now notice we also have this other point. It's going to become really important in just a second. You're going to see, because this one, for convex limisons, it doesn't have a lot of symmetry to them because it's kind of that flat tire. So we're not going to get a lot of points out of it. Like when we draw our roses, we've got lots of ends of rose petals. We know our zeros. There's lots of points to help guide us. For the convex limisons, we really just have this guy here, and you're about to see no zeros. So next step we would do is find our 0, but when we plug this guy in and we subtract the 5 over to find our 0, when we divide by -1, then we're going to ask ourselves, where is cosine theta equal to 5? Well, it's never equal to 5, right? We said cosine theta oscillates between -1 and 1, so this is never true, which means we have no zeros. So now we're stuck. We only have 1 point. So we're going to actually have to go look for some others. We do have another point. We said if cosine theta was 1, our R value is at 4. Well, cosine theta is 1 when we're at 0. So we know at 0, our R value is 4. And then we could find, like, say, pi over 2 or 3 pi over 2 to find a couple other ones. So where would we be at, say, cosine pi over 2? Well, cosine of pi over 2 is 0, so this becomes 5 minus 0. So at pi over 2, we're at 5. Same thing for 3 pi over 2. 5 minus cosine of 3 pi over 2. What's cosine of 3 pi over 2? That's also 0, so we are also at 5 when we're at 3 pi over 2. So we kind of get that wonky shape for it. It's going to be rather roundish in nature, except for it's kind of flat on this side. It doesn't go all the way out to 6. So it doesn't look exactly like a circle. It doesn't look like this shaky mess that I drew here. And it's not exactly a circle. If you want to see a much better picture of that, go put it into Desmos. All right, that's it for number 17. Coming up next will be number 18.